So, let us begin. Why doesn't an insect sink on water? A journey into surface tension and fluid mechanics. By taking a look around us, you would see that insects float on water, which kinda looks like magic, but it's actually pure fluid mechanics. By taking a physical observation, we see that small insects float on water and the surface bends but it doesn't break. And apparently, the density of the insect is higher than the density of the water. From this physical observation, we can say that there is a downward force working downward, which is the weight of the insect, and there is an upward force. And these two forces must stay at an equilibrium so that the insect can float on water. So, what about this upward force? This upward force is basically the surface tension. And to understand surface tension, we have to start with this movable wire, which is connected with this frame. And if this whole system goes into liquid bubble water, we would get a surface of film. And if we take a side view, we see that this is the cross section of the movable wire that has two surfaces and that is associated with two coefficients of surface tension. Now, if we have to balance this force, we have to apply equal and opposite amount of force, that is F. And this whole system basically gives us this particular equation, where P is basically the length of the movable wire. Now, to understand surface tension better, let us look at this picture where there is a molecule that is at the surface of a liquid, but there is no liquid at the top of the molecule. This creates an imbalance and a net attractive force that works toward the interior of the fluid. So, how is this surface tension associated with a floating insect? What we have to do is just replace this movable wire with the leg of an insect. Now let us take a look at a floating insect. This floating insect has two legs and they have length L1 and L2. Now if we just replace this leg with a movable wire, don't we get the same equation? Don't we get the same equation? Yes, we do. So what we have to do is just replace this B with this L. And this F sigma would basically be the governing equation of a floating insect. And as we have mentioned before, there must be an equilibrium between F sigma and the weight of the insect. The force balance becomes F sigma prime is equals to W. This F sigma prime is basically the component of surface tension that is working vertically upward, and there is a downward force which is the weight. And these two forces basically counterbalances and keeps the insect floating on water. So that's basically the conclusion, and that's how insect floats on water.